Okay, let's get started. Having some technical difficulties, but I'm on now, so I apologize for that. Let's see. This code here, I want to make sure I had the right project open, was what we went over last time. We looked at how to add using a for loop and add using a while loop. I wanted to show you one more example using these concepts, or at least one more, maybe two. We'll see. Not going to show you how to build a list box anymore. Java Maven, Java application, and finish. Expand source packages. Right click on here and I'll say new JFrame form. And let's see, it's triple label on there. Right click on that, edit text, number, and text field. Right click on that, edit text, backspace, resize it, give it a name. So right click, change variable name, TF underscore number. The button, right click, edit text, and I'll have to say calculate. Calculate. I don't know why I have so much trouble with that word. Calculate, I think that's right. Give it a name, right click, change variable name, I'll call it button, calc. Okay. And label down here, and let me go ahead and put another label. This is where my answer is going to be. So I'll right click on this one, change text, and answer. This one, I'll edit text, and I'll just put 0 there initially, I guess. I highlight all these. I click up here in the upper left-hand corner with my left mouse button, hold down and drag, and just select them all. You come over here to the font, and I want to change it so I can see. There we go. Now, I'm going to program one out of the book. I thought it was an interesting one. I never have done this one, so we'll see how this goes. Let's say you're given number A and you want to find its square root. One way to do that is to start with a rough guess about the answer x naught, and then improve the guess using this formula. For example, if we want to find square root of 9, we start with x naught is equal to 6 and go so forth. Okay, so let me right click on this and I'll say events, mouse clicked. Now, specifically how they want us to do it is they want it to be a separate function. Write a method called square root. I could put in even a separate class here if I wanted to, but I'll just put it here. And int, well, I guess double. Doesn't have to be a integer, I guess. Double number and answer. Number is equal to double dot parse. I expect it didn't pop up with the choices there. There it is, parse double. I need those little tricks to help me number.getText. I think that returns as a string, so I don't need to do the dot on that. So I'll take my string there, and it'll convert it to a double, a number with decimals, and assign it a number. Okay, so I'm going to call public double, what did I say it's called? Square root? Not that it matters. Square root. Yeah, double A. And my answer, then return my answer. Okay. Line up initialized. So we're going to keep doing this over and over until the difference is 0.0001. But it says as your initial guess, you should use A divided by 2. So X naught will be my initial guess. So X naught. So X naught is equal to A divided by 2. Now, I'm going to continue while something's true. That's pretty vague, isn't it? I shouldn't say X naught. Let me just call it X, because it could be X naught, X1, and so forth. Now, if you're not really big into math, don't like stress over this example. You won't ever have anything that's hard in the business world or manufacturing, finance. I'm going to have a while here of some sort. I'm going to come back to that. And then my new X is going to equal to the old X plus A divided by X divided by 2. So X is equal to X plus A divided by X divided by 2. Okay, so then that'll keep going through and doing that. And I want to continue over and over until, it gets 2 consecutive estimates are different by less than. So I want the old value of X and the new value of X. So where would I set the old value of X at? Old X equals 2X. Of course, I got to declare old X. Okay, so then I calculate my new X here. And while I guess I want to figure the difference of them, difference is equal to the absolute value, math dot absolute value of X minus old X. So we're calculating our new value, and we're finding the difference between them and taking the absolute value so it's positive. So while the difference is less than, greater than 0.001, we want to keep doing this process. So initially, I need the difference. I have that declared. I don't think I see difference declared. Yeah. Initialized. Okay. Diff is equal to 1. I just give it some kind of bogus value to begin with. Okay. It definitely would be greater than 0.0001 there, so then I calculate that. And variable answer might not have been declared. Okay, let me just say answer equals something, just to make it happy. And now, when this is done running, my x should be my value I want to return. So answer equals x. I'm using more variables than I need to, but that's okay. And I return the answer. Now, when I return the answer, I want to have it equal to a variable here, and square, what I call it, the square root of number. So this is going to call this method here, square root, pass in the value. It'll hopefully go through and do the code that they described, though not something about absolute value. I'm just drawing a real blank. The languages are mixing together. I didn't think I had to import math. What am I doing wrong here? Java import math. Java.language.math. Uppercase M. Can I find symbol? Square and then uppercase R. Okay. Now when I get that, I can then do my, I didn't name it. That's no good. This is where my answer is going to go. So we right click on that, change variable name. I'll call it LB underscore answer. And then here I'll say LB underscore answer dot set text string dot value of answer. Okay, so let's run that. Put 4 in there, 2, if you put 2 in, 1.41. So if you ever wondered how do I got 2 open here. There we go. If you ever wondered how can I calculate square root by hand, the approximate, square root of 9 is easy, but like square root of 2, how would you do it? Well, this is how you do it. Okay. That's probably all the exciting part on that one. Now, let's go ahead and do a factorial. Mainly because I want you to have it, so I'm going to assign section 7.5. So I want to see how you do on that. It's kind of it's a little bit of a challenging one. Maybe I won't. That's a little bit too challenging. I'll program it though, so you can see how to do that. I could assign exercise 7.3 that would use loops. Okay, so let me come up with a new project. And after this, we'll go on to the next chapter. Next chapter is a little bit longer. It'll take us a little bit more time because it's arrays. The arrays are a little bit different. Okay, new JFrame form. And I don't know what I'm calculating. Okay, e to the x power. So I need to pass in x. E, if you haven't had mathematics, is 2.7 a bunch of decimal places. So like 2.7 bunch of decimal places. The first power would be 2.7 bunch of decimal places, so forth. Okay, so I click on this, edit text, program to calculate e to the x power. This one's going to be edit text x. Text field, right click on that, edit text, do a backspace, resize it, name it, right click on all this, tf underscore x. Need a button, right click, edit text, calculate. And I'll name it, right click, change variable name, button underscore calc. Okay. For our answer now, come a label here, right click on that, say edit text, answer. Take that, bring it down, right click on that, edit text, I'll say 0 initially, and I'll right click on it, change variable name, I'll call it LB underscore answer. Click up here and hold down my left mouse button, drag, it does a rectangular select, selects everything. And choose something I can see, take 24. Okay, calculate. Okay, so right click on the button and choose events, mouse clicked. Okay, so I need to, one thing I noticed here is that I got factorial. 4 factorial, 3 factorial, 5 factorial will be over here. Going backwards again, 2 factorial. This would be 1 factorial, and this would be 0 factorial. So they're actually all of them there. I'm not going to do this clever. I'm not going to do it with recursion or something like that. But I do need a method to calculate factorial. So public, need return. What's factorial going to be? Integer? We'll say it. Calculate factorial, and I'll pass in an integer. This would be like I'm calculating 5 factorial. So int fact's equal to 1 initially, and then I'll do a for loop for int x equals, where do I want to go from? 1? 1 probably doesn't matter, but I'll start at 1 just to make it self-documenting. Less than or equal to number, and then x plus plus. So for example, if I enter in 5, it'll go 1 to 5. Very simple. Now fact is going to equal to fact times x. And then I return factorial. One thing I want to be sure of on this is that it handles if I put a 0 in, because I'll have to need that for my code. If I put 0 in, it'll continue while x is less than or equal to 0. So 1 is less than or equal to 0, since it initializes it to 0. So it won't do that. But fact is equal to 1, so that works fine. Okay, so that calculates my factorial. Now down here, I could put this in a separate method, and they do say use a separate method, so let me do that. Because that'll show you one method calling another method. Public double my, they say to name it my exp. That takes x and n as parameters and estimates. So I'm going to take x and n. X. Yeah, you can have decimals. I had to think about that. Stayed up a little bit too late last night. Mainly because I took a nap when I got home. I couldn't get to sleep. Wasn't trying to stay up. Okay, and then n is the number of terms, so I can be an n. Or an integer, sorry. Okay. Now the n is going to be how many we have. For example, this is probably n is equal to 2, n is equal to 1, n is equal to 0 to make it easier. Okay, let me take my headset off and go do my. Well, I can reach over there. Need to hook my tablet up. Just so we understand what I'm doing. Okay. What is this? This is x squared over 2 factorial. This one is x to the third over 3 factorial. This one is x to the fourth over 4 factorial, so on. This x here, that's actually x to the first over 1 factorial. 1 factorial is 1, x to the first is x divided by 1 is x. And the 0 is x to the 0 over 0 factorial. You might not know this if you're not big into math, but anything to 0 power is 1. 0 factorial is 1. 1 divided by 1 is 1. So even though it appears like, well, it's a pattern except for these first two, no, if you write them all out, they are a pattern. So first thing, you see this 0, 1, 2, 3, 4. That's going to be our n. So let's go ahead and program that first. There we go. 4 int index, excuse me, equals 0. Continue while index is less than or equal to n. And then index plus plus. That's going to handle 0, 1, 2, 3, 4 up to n. Now, if n is how many terms we have of this, or how many fractions, I should actually go to n minus 1, but it doesn't matter for what we're doing. Okay, so my answer is going to be a double. And I'm going to set it equal to 1 or 0. 0 initially because I'm adding. Whenever you're adding items, you always set it equal to 0. If you're multiplying, you set it equal to 1. And then my answer is going to equal to the answer plus, and I'm going to take 1 divided by, and then I'll calculate factorial. And I'll be passing in index. Okay. And then down here, I'll return answer. And just didn't like this right here, but I'll come back to that. So what is this doing exactly? The answer is our answer, of course. Index are explained. And then this is doing a plus, and then we got a factorial on the bottom. So index is 0, that'd be 0 factorial. Index is 1, that's 1 factorial. Index is 2, that's 2 factorial, and so forth. So this is going through and doing all the bottom part. Okay, now I put a placeholder of 1 on top. Let's go back and address it. It looks like these I'm raising to a power. And probably they don't want us to use the POW function, if I had to guess. I'm assuming they don't. Well, it doesn't say. Use this observation to eliminate the use of math.pow in factorial. Okay, I'm not going to do that part. Let's put math.pow in there then. Okay, so the top part. We're going to have x to that power. So x is being brought in right here. So I'm going to do a math dot pow, and I'll pass in x and then my power, which is index. That'd be x is 0, x first, so forth. Okay, so then down here, now I've got my methods written. I can, and you notice this is going to call my exp, but my exp calls another method. So you can have one method calling a different method. Okay, so I want to get those, the x, what is x? It's double x. X is equal to double dot parse double tf underscore x dot get text. And in. What in the world's in? There's two ways of approaching it. You could have an input in, or you could continue until the difference is less than a certain value. Difference is usually a better technique. That way it'll ensure you get a certain amount of precision. In's easier to program, so I could have them input it, but I'm going to do the difference, just because it'd be easier or nice, better. Okay, so I'm going to have old answer. Well, I got this program for in though. I don't got a program. They want us to do in. Okay, never mind. So I need to pass in. Okay, so okay, so this is gonna be in. You can right click on these and choose duplicate. That way it keeps all of your fonts and so forth. And change variable name. I'll call this tf underscore in. Back to my code here. In has got to be an integer. Int is equal to integer dot parse int tf underscore in dot get text. And this is going to return a double, which means I need to assign it to an answer. And answer is going to equal to my exp, and I'm passing in x and n, I believe. Yep, x and n. Return it to answer, and then lb underscore answer dot set text string dot value of, and then answer. Okay, so let's run that. Actually, x would, let me think. X is like e squared. Yeah, they are two different things. Never mind. Okay, first here, and I put in 10. Okay. So if I put in 3, gives me that. Let's equals exp of third. $20.0855. I got some issues here. Let's change this to 100. Okay, can't do a factorial of 100. 20. It's interesting, it's further away than the previous one. That would imply maybe I don't got the right code. I'm probably not understanding the. Let's see what this says. E to the third. X is 3. So it's right when it's smaller. I'm just math-wise, I'm wrapping my mind around why it would be becoming an issue when you go bigger. You should be getting a better precision, not worse. Um, big integer. Data types. I think it's long. I think that's the one that's okay. So let's come back over here. Okay, where's this called from? It's called from here. Hmm, passing in index, which is an integer. That should be fine. Okay, 20. It's just third power, wasn't it? There, that looks better. Okay, so let's put in a bigger number here. Let's put something in not that big. About 50. Fact it's negative means it's getting confused. Well, that's probably as good as we're going to get. The problem is that when n becomes huge, your factorial become what? Well, you say n is not huge. Well, it is when you talk about factorial. 35 factorial is pretty good size. So that means one, and you move your decimal point 40 places to the right. So huge number. Um, so as it becomes large, then that messes it up. Um, and there's really no way around that in terms of the factorial with what we're doing. There's other ways to program that, of course, but okay. Well, that shows that one. Like I say, that was kind of a challenging one, so I thought I'd better not show that, or maybe better not assign that. Um, I might sign that one since we're covering factorial now and POW using these looping constructs. Then this one might not be too bad. Okay, let's start talking about arrays. We won't get all the way through this, but we'll get started, and then we'll get through it eventually. Arrays in a list of something. For example, if I go over to Excel, and I got some numbers here: 7, 2, 5, and 3. A list of integers. Now, 7 is our first number, 2 is our second, 5 is our third, and 3 is our fourth. In programming, our indexing, our numbering starts with 0, not 1. So that's our 0th number, first number, second number, third number. Now, the length of the array is still 4, but we have to reference them this way. And there's a reason why. It's how the storage. Well, this is one reason. This is how the storage is done in memory. An array might be contiguous blocks of memory, and so when you're talking about the first number, it's the 0 for the index refers to the offset. There's no offset because it starts there at that memory location. Then this would tell you that there's an offset of 1. The 1 wouldn't be like the size. is based upon the memory configuration, but maybe it might be an offset of 8 bits or 16 bits, whatever the hardware architecture might dictate. And then this is offset of 2 and then a 3. So these help tell where everything's stored at in memory. Now creating arrays. You have your data type, int, double, boolean, whatever string, whatever you have, and then you have a beginning bracket, closing bracket, and then you have your name. Okay, so let's come over here and I'll do a simple project. We'll do something a little bit more interesting next time. Okay, right click on that, new JFrame form. Okay. And I'll have a button. This will be as boring as can be, and a label where we'll write our answer. Let's see, change variable name. I'll call this LB underscore answer. Right click on this, edit text, calculate. And right click on that and say events, mouse click. Okay, so here I want to declare my array, int, and remember we use brackets. That tells us the difference between an array of integer or just an integer. And I'll call it nums. Now this next part is where we create a new. This is how we create the array. You have to use a new operator, which we first saw in section 3.2, and we give it a size. So, oops, what happened here? Okay, there you go. Nums equals new int 4. The new, you can think of it as like we're creating a new instance of it, a new entity of it. Int repeat with the numbers and then 4. Notice here we've got size. This would be so if you're passing like the size of the array to use into a method. Within the method, you can use a variable there or a constant instead of hard code a number. You can combine together the declaration and the creating the instance of it. Now accessing elements. We already talked about how it starts at 0 for an index. So my first number, num0. Let's put the same numbers we put over here in Excel. First number 7. Nums1 is equal to 2. Times 2 is equal to 5. Nums3 is equal to 3. Now you can also, instead of hard coding these values here, you could dynamically get those. Maybe you'd ask the user for it. Which one do you want to change? By the way, you've already worked with arrays. Remember the model that we created? That's an array. That's a list of items. Remember how it went from 0 and then you went to the mod size, less than the mod size? Exact same principle as what we're doing here. So if I want to add these numbers together, x equals 0, I want to continue while x is less than 4, because I want to go to 3, x plus plus. Guess I need a variable for sum. Set equal to 0 initially. And here I'll say sum is equal to sum plus nums x. Now lb underscore answer dot set text string dot value of sum, like that. Just check this, make sure it works, which should give us 9, 14, 17. Yeah, 17. Grab another pop. Yeah, we get 17. So nothing exciting there. Now let's talk about the code. With arrays, since I had my x loop from 0 to 3, then I could put a variable here, and that would change each time through. First time x equals 0, next time x equals 1, x equals 2, x equals 3. What happens if I go to 4? Program blows up. It does not exist out there. Excuse me. Now, other languages will allow you to do that, but it will get bogus results. Like C. C and C++ do not have a checking on exceeding the size of the array, and so you can access memory that isn't part of the array and get weird results. But it doesn't blow up. It just gives you wrong results. So again, make sure if you say your array has 4 entries, make sure you're just accessing those 4 entries, basically. Okay. Displaying arrays, print array, copying arrays. This talks about that. I'm not going to go over that. I'll let you read about that in the book. Hopefully you're reading the book, because I'm not covering everything in class. But this shows a way you can copy individual elements within an array. So that's how you make a copy of it. You can also use java.util.arrays, which provides many methods, one of which is copy of. That opens the copies an array. Import java.util.arrays. And then down here, you see there's a lot of items already programmed for you. Binary search. Compare, copy of, copy range, equals, fill. I couldn't tell you what all this does. Mismatch. Parallel sort. I'm not sure what a parallel sort is. Sort. Next time we'll be looking at how to program a bubble sort, but you actually don't need to because it's built in with the language. So there's much more than just that the copy that they're referencing. There's a lot more when you bring that in. This is not. This is the process of not reinventing the wheel. If somebody's already written a sort, then we go with that. Now let's see if I can figure out the syntax of it. And then I'll write it out to the answer box here. I already did the sum. And okay, so I think I have to do nums. We'll see if this is correct. Arrays dot sort. Sorts a specified array of objects in descending order. And it doesn't return anything. See the void? So when I'm setting it equal to nums equals, I know that's wrong. Use the documentation. Understand what these words mean. If you understand what those words mean, then it makes your life a lot easier. So I know I don't have to do the nums equal. I didn't have to Google it. And then we're sorting nums. Okay, now at this point, nums should be sorted from smallest to largest. So I'm gonna have a loop here, and I'm gonna write it out to this answer blank. So let me come up here. String s answer equals to empty. For int x equals 0, continue x is less than 4, x plus plus. Excuse me. Then let me think. S answer is equal to S answer plus, that's a concatenation, we're talking about strings. String dot value of x, not x, nums x plus, and I'll put a space there. Then down here, I don't need to do a string dot value of because it's already a string. I'll print out the S answer. 7, 2, 5, and 3. Okay, so if I do that, you see how it's sorted. I'd be tempted not to even show you the bubble sort, but some of you going on to four-year college and you have to take a data structures class, and part of the data structures class is to program a lot of sorts yourself. There's different sorting algorithms. List. You'll be shocked how many of these are. And searches too. Okay, here, stooge sort. Selection sort, bubble sort, recursive bubble sort, insertion sort, recursive insertion sort, merge sort, iterative merge sort, quick sort, iterative quick sort, heap sort, counting sort, radix sort. Okay, I'm really curious about stooge sort. I hate recursion, so I'm not going to try to program it. Okay, value is at index 0 is greater than value at last index, swap them. Step 2. At index 0, so it's always 0, is greater than value at the last index, swap them. Recursively, stooge sort the initial 2/3 of the array. Stooge sort the last. Stooge sort the last 2/3 of the array. What in the world? Choose sort the initial 2/3. Again, to confirm. Not a bad site. Shows you exactly how things are sorted and so forth. Stooge sort. Anyway, I'm not going to have time to program the stooge sort. Interesting, though. Okay, so projects. I want you to, and this, I'll choose something out of the book too. This is the second project. So I'll start with it. Project 2. I want you to have an array, 5 numbers. Use random numbers to populate the array. And they can be integers. Okay, I didn't even talk about random numbers today, and I'm not even sure if I've talked about them, period, to be honest. You come to Google. I want you to get used to going to Google. I want you to start extending just beyond what I'm showing you how to do. But I do want to show you how to do the sort. And you start searching for Java random number and figure out how to do it. Here's random number between 1 and 10. I probably wouldn't choose stack overflows. That's usually when somebody can't get something right. Some of these other ones might be better. Although I do get answers sometimes from Stack Overflow because somebody will answer it, and then I can look and see what they did and get the answer that way. But again, use random numbers to population the array. Populate. Go learn English after this. Okay, populate the array. Then loop through the array. And add it into a list box. I'll call it list box. Remember the model we looked at last time? So the model. So you should have the idea here. Oh, open recent project. You should have a button that you click. When you click the button, it chooses random numbers using, and you'll read about how to do it, but you have to import and so forth. But anyway, it gets random numbers, puts them into an array first. Don't directly drop them into the model, but populate an array first, then loop through the array, putting your numbers in here. Okay, so that's the first one, or second one, I should say. Let's go back. I want to spend. No, we're not done with that chapter. I want to spend a little bit more time on arrays. Arrays are interesting. And just by doing a simple example like I just did, you can't really see the power of it. So I try to choose a programming project at the end. Okay. This is actually very close, but I won't sign it. I was going to, but then okay. So the problem number 1 on page. What page is this? I hate how PDF page numbers are. Oh, they're the same. 120, 120. So page 120. Okay, exercise 7.3. It was talking about recursion there. And it says in exercise 6.9, we wrote a recursive version of power, which takes double x, the integer n, returns x n. Now I write an iterative method to perform the same calculation. So we don't have to do recursion. I was seeing that recursion. It's like, oh, there's no way I'm going to sign that. I'll have 90% of the class contact me with trouble doing it. Now, again, I'm showing this. If you want to do something more challenging, go through. Don't do the one I did, but do 7.6 instead. Let me put that here, actually. Your choice. 7.6, I think, is a more interesting one, but you have to really think about how to handle it and so forth. 7.3 is a more easy problem to perform. Why would you want to do the harder one? Well, part of you taking a programming class is you want to get good at programming. So you hope to do for a living. If it's something you're going to do for the next 50 years of your life, why do you want to stink at it? Get good at it. It's not like a Shakespearean class that you're going to read about Shakespeare one time and never use it again. This is job training basically, and you should challenge yourself. When I went through here, and I was trying to figure out which ones to program. The ones that looked hardest to me were the square root one, which I did, and this one, exercise 7.5. I'm not quite sure if I'm comfortable with how I did 7.5 due to the fact I couldn't get the precision I wanted to. But I performed it based upon the formula, which is all I can do, and limitations of the data type. Anyway, those are the two projects for this week. I guess we'll go ahead and stop there and have a good day and good weekend.